actually I'm taking a 4-bar mechanism here. Okay, so this is one link, and this is another link. Okay, so this is a 4-bar mechanism, and this link is fixed. I'm giving some names. AB is one link, and sorry, this is A, B, C, D. Okay, AB is AD link is fixed here, and this is link 1, link 2, and link 3, link 4. Okay, so there are 4 links, and these are all hinge joints. Okay, so it's a 4-bar mechanism, and here actually the number of instantaneous centers we can locate by we can calculate by n into n minus 1 by 2. So number of links, capital N is nothing but the number of instantaneous centers, and small n is the number of links. Here the number of links are 4, so 4 into 3, 4 minus 1, 3 by 2, so there are 6 instantaneous centers. So we have to locate all the instantaneous centers. So to locate all 6 instantaneous centers, by seeing the figure, okay, by seeing the mechanism, we can able to locate some of the instantaneous centers. So first, if we observe this 4-bar mechanism, what we can understand here, actually the link 2 is rotating about link A, link 1 about A. Okay, the link 2 is rotating about link 1, okay, relative to link 1 from about point A. Okay, so now by seeing this, actually I12, okay, I12 is at the point A, okay, at the hinge joint A. So I12 you can locate. And also the link 4 is rotating about point D, and link 1 is fixed. Okay, so it is 1 4. Okay, instantaneous 1 4. So actually you can say that actually when these 2 links are rotating, when the link 2, 3, 4 are rotating, okay, this link is fixed. Okay, so these 1 2 and 1 4 are fixed instantaneous centers. Okay, when the configuration of after some time the configuration of this diagram, okay, this mechanism may change, okay, because the link AB is rotating with some angular velocity, but instantaneous 1 2 and instantaneous 1 4, the position of the instantaneous centers are not changing. They are fixed instantaneous centers, and they are always located pin A and pin D. Okay, so these we call as a fixed instantaneous centers. And now actually we can say that the link 3, okay, the link 3 is rotating, okay, relative to link 2 about point B. Okay, so this is you can say instantaneous 2 3. Okay, instantaneous 2 3. And here the link 3 is having relative motion relative to link 4 about point C. That means the link 3 and link 4 are moving about point C. Okay, about this hinge joint C. So this is the instantaneous center 3 4. Okay, so actually this is the instantaneous 2 3 and 3 4 are also at the joints B and C, and these are not fixed. Okay, if after some time, if the link AB is rotating with some angular velocity, the position of the instantaneous centers 2 3 and 3 4 are changing, because it will take the B position and C position will take another positions, okay, due to rotation of link AB. So these are not fixed instantaneous centers, but they are permanent. Okay, why we are saying it's a permanent instantaneous centers? So actually this instantaneous 2 3 and instantaneous 3 4 always at the joints B and C. Okay, so they are permanent instantaneous centers, okay, but they are not fixed instantaneous centers. Okay, so by seeing the configuration, okay, by seeing the configuration of the mechanism, you can easily locate some of the instantaneous centers. But here the number of instantaneous centers we can calculate by 6, but we can observe, okay, by observing the diagram, actually we can locate some of the instantaneous centers. So the remaining instantaneous, how we look at actually what we remind, actually what instantaneous are remind. First of all, actually we should understand this. To locate all the instantaneous centers, first you draw one like this, okay, because actually first you draw 1 2 3 4, okay, you just write like this, okay, these are the number of the links, okay, here the number of links are 4, so I am writing like this 1 2 3 4. Okay, so now I am connecting 1 2 here, okay, I am connecting 1 2 here, so this is the instantaneous center 1 2, okay, and I am connecting 2 4, okay, I am connecting 2 4, so instantaneous center 2 4 is sorry, here, okay, you can say this is 3 and this is 4, okay, 2 3 you can locate here, okay, so 1 2 3 4, and 1 2 you already located, and join 2 3, and 2 3 we already located, so 3 4, okay, you join 3 4, so it is located 3 4 here, and 4 1, okay, so you just join 4 and 1, so 1 4 or 4 1, okay, same, okay, so we located, because why 1 4 and 4 1 are same, because actually instantaneous center is a point about the relative motion between, okay, the 1 4 is nothing but actually the link 1 and 4 having relative motion about this point, so it is the instantaneous center 1 4, and 4 1 is also same, the links 4 and 1 are having relative motion, so 4 1 and instantaneous 4 1 or 1 4 are the same. Okay, so normally we used to locate by ascending order, okay, 1 4. Okay, so now what are the remaining, okay, what are the remaining eye centers? So I'm just drawing here 1 2 3 4, okay, so all 1 2 we located, and 2 3 we located, 3 4 we located, and 1 4 we located. So the remaining eye centers, okay, these are the eye centers we located by observing the configuration. So now we will connect the corners, okay, we will connect the corners. So here actually 1 3 is one eye center we have to locate, okay, 1 3 is one eye center we have to locate in this, okay, that is the fifth, okay, another eye center, okay, we have to locate. So to locate this 1 3, okay, eye center, that means we have to consider 3 links, okay, we have to consider 3 links, that is 1 2 3 you have to take, okay, 1 2 3 they are having relative motion, so here the link 1 2 3 they are having relative motion. So to locate 1 3 we use Kennedy's theorem. So the location of the eye centers actually on a single straight line, okay, on a straight line, so that is the Kennedy's theorem. So now we will take to locate I3 we take the links 1 2 3, okay, 1 2 3. So if you take link 1 2 3, 1 2 already we have, okay, 1 2 eye center we located, and 2 3 eye center already we have. Another eye center is 1 3, okay, another eye center is 1 3. So now because by using the Kennedy's theorem, what we can understand, all these 3 eye centers are on the same straight line, okay, right? So now what we will do, we will just extend this 1 2 and 2 3, we will extend this straight line like this. Okay, we will extend this line. Okay, so now 1 3 is the eye center which will be on this straight line. Okay, we extended because 1 1 2 2 3 and 1 3 are on the same line. Okay, by using the Kennedy's theorem. Okay, so now 1 3 is on this line. Okay, so again we take 1 4 3. Okay, we take 1 4 3 links. Okay, if you take 1 4 3, okay, that means these 3 links, 1 4 3 links, the instantaneous centers are 1 4 and 3 4 and 1 3. Okay, so we already know 1 4 and 3 4. Okay, so these are the 1 4 eye center and 3 4 eye center. So these three are lie on the same line by using the Kennedy's theorem. Okay, so now we will extend this line. Okay, this CD line. So the meeting point will be eye center 1 3. Okay, the meeting point will be eye center 1 3. So we located I 1 3 also. Okay, I 1 3 also. So another eye center, because it is having 6 instantaneous center, so we have to locate the 6th eye center. So we just connect the diagonal here. So eye center, the third one, okay, the 6th one, the final instantaneous center is 2 4. Okay, the final instantaneous center is 2 4. For this, to locate instantaneous center 2 4, we will take 4 1 2 links. Okay, 4 1 2 links. Okay, and now actually if you take, because we are taking 4 1 2 links, these 3 links have relative motion, okay, with each other. So if you take these 3, actually the instantaneous we have 1 4 1 2 and 2 4. Okay, so these instantaneous centers will lie on the same line. Okay, so we already located 1 4 here. Okay, 1 2 here. So we will extend this line. Okay, we will extend this line. On this line, somewhere actually the 2 4, the instantaneous center 2 4 will exist. So actually we have taken 4 1 2 here. Okay, so now we will take 4 3 2 links. Okay, we will take 4 3 2 links. Okay, so the instantaneous center will be 3 4 2 3. Okay, 3 4 2 3 and 2 4. Okay, because we have normally we use in ascending order. Okay, so these 3 lie on the same line. So 3 4. So 3 4 and 2 3. So we will extend this line. Okay, so this is the intersection point of this line, and this line will be instantaneous center 2 4. Okay, instantaneous center 2 4. Like this, actually we will locate the eye center. So eye center is nothing but there is a relative motion about that point. About this point, if you take the link 2 and 4, okay, the meaning here, actually the link the eye center 2 and 4, that means this is the 2 and this is the 4. Okay, so actually about this point the velocity is 0. Okay, there is no you can say that the link 2 and 4 are at rest, okay, relative to each other. Okay, so that is the meaning. Okay, so like this actually we will locate the eye centers. If more number of mechanisms, okay, links are there, actually normally we used to locate all the instantaneous centers. So how we do the velocity analysis, okay, next class we will discuss. Before going to discuss the velocity analysis by using these instantaneous centers, we have some rules here to locate eye centers by inspections. Okay, so first actually we will try to understand what are the rules. Okay, rules to locate eye centers by inspection. Okay, what are the rules? Okay, so by inspection, actually we said actually some eye centers we can able to locate. Okay, well, some instantaneous centers are fixed. Okay, and some instantaneous centers are permanent. Okay, so we can locate, and other instantaneous centers we can use by using Kennedy's theorem, we can locate. Okay, so now if the two links are connected by using a hinge joint. Okay, so this is the link 1 and this is the link 2, so there is a relative motion. Okay, okay, between the link 1 and 2, and this link 1 and 2 are have connected by a hinge joint here. So instantaneous center 1 2 will be at the hinge. Okay, in a pivoted, normally what we can say, in a pivoted joint, the center of the pivot is the eye center for two links of the pivot. Okay, so this is the pivot, so we can say that the instantaneous center 1 2 will be at the joint. Okay, so another one, actually, because normally we located like this, because actually the link 1 and 2 are having relative motion. Okay, so it is at the pin joint. Okay, so we can locate it like that. This is a general rule, actually, what we can actually, if there is any mechanism, you can easily identify the eye center. Okay, if there is any pivot joint, then this is the eye center at the pin joint. Okay, between the links, relative motion. Okay, so next one, actually, if there is a slider, okay, this is a slider, and this is a fixed link, and this is a link 1 and this is link 2. Okay, so eye center 1 2. Okay, eye center 1 2, because this is a slider, and if you draw a perpendicular line, it will be like this, right? Okay, and actually here what will happen, eye center will lie at infinity. Okay, because if you take a point A, okay, and it is moving. Okay, so this is VA here. Okay, and if you draw a perpendicular, this is the thing. Okay, and the slider is moving like this. Actually here, this is the point B, you can take, this is the VB. So actually eye center 1 2, the lines are not meeting. Okay, the lines are not meeting, so 1 2 at infinity. Okay, in a sliding motion, generally what we can say, in a sliding motion, the eye center lies at infinity in a direction perpendicular to the path of motion. Okay, path of the motion of the slider. Okay, so this we have to understand. And also one more thing, if there is one link here, okay, the shape of the link here is this one, and a roller like this. Okay, so this is a roller, and this is the link 2, and it is rotating, and you are considering pure rolling. Okay, and if you are considering pure rolling, so if you are considering pure rolling, the instantaneous center is at the contact position. Okay, the instantaneous center is at the contact position. So these things normally we have to understand and to locate the eye centers in any mechanism. So I will stop here, and next class we will try to understand, we will extend our discussion how to do the velocity analysis by using eye centers, and we will do some of the problems, okay, by using these instantaneous centers. Okay, so thank you.